Hi. So I wanted to talk about CI and automation today. In particular, I think that there's a lot of people that I personally know or have mentored that don't fully grok automation. And I think that there's an aspect of progressing as a software developer and understanding not only kind of this path of first learning how to birth ideas or projects, but also taking them into production and watching them and doing operations around them, and including like carving out the infrastructure around that, and then also taking it to the grave and actually deprecating it and making space for new. Like deletability is a really important concept, at least to me. So my plan for today was to kind of go over what is CI and automation. So I won't go into the deep history about continuous integration and the history of the word and the history of the, ethos around that. What I will say is that this was originally inspired by two tweets, and I will also actually write a blog post and put that in the description somewhere, that had to do with people having this common lament about their GitHub repositories being like graveyards of good intentions, right? Lots of started projects, they never finish. They kind of just get left behind. The dependencies never get bumped. They never build again. And there is a certain amount of bitrot, right? With projects, you write something and then later you come back to it, you try to build it and just won't build, right? Tools advance, dependencies advance. I wanted to kind of discuss this idea of how to take projects in your GitHub repository or wherever it is. It will be GitHub today for us, because that's what I predominantly use. I'm not endorsing anybody. I want to make that crystal clear, but it's just what I use. And GitHub has this new thing called Actions, so it'll actually be a really simple way to integrate a CI and some automated steps for us. So what is a CI? A CI is basically a way of automating tasks on some pipeline based upon triggers, right? So you push some code, and then the CI picks that up, puts it in the job into a queue. Some build bot, right, takes the job off the queue and then runs that task. That's generally how a CI is set up. There are several CI SaaS offerings. So SaaS, if you're not familiar with it, is software as a service. Some would claim that a CI is a PaaS, so platform as a service, but it depends. It's not really important here. The general idea is that you can specify steps, usually in YAML, to a CI provider or CI software or whatever, and then these steps get carried out by build bots, right? So there's YAML, and that has its own ins and outs, but really most CIs nowadays are just specifying steps in YAML. The breakdown of a CI is effectively this idea of you have builds, right? Some people call them jobs, and then those individual jobs or builds have steps in them, and each of those steps can do things. And so this can be things like running tests, building artifacts, deploying versions of sites, uploading artifacts. There might be caching involved, so pushing out things and pulling them in. But I wanted to kind of push the idea further in a series of videos where we explore really setting up a project in a way that doesn't have to do with treating it like a graveyard of good intentions or like an uncared for collection of plants, right, was the other tweet. I think that people can have that perception about projects, but it's really easy nowadays to set up a project and have it kind of mostly take care of itself so that you can come back to it. It's kind of nice too, because what doing all of this does is it actually lowers friction to return to projects. A really great example of this is like laboratory repositories. So you might have like a lab repo, right? And instead of going around forums and Stack Overflow or whatever and asking questions, you might just write some code to answer a question immediately. And having a good CI and a whole bunch of other stuff will let you actually it will reduce the friction for you to get back into that repository and make changes and answer those questions. All of this is effectively going towards a single aim, which is to automate away all the toil, right? And that's a part of the friction, right? If you've got a whole bunch of chore-related stuff you need to do back in a project, there's a really low chance you'll get back there. But if you make it really fast, right, even to the point where your CI is faster than you running the tests locally, which can be possible in some cases, right? Maybe you're not doing caching locally and on CI you are, right? Maybe there's some shared cache that you have as a service. There's lots of cool configurations and ways, and I don't know if we'll even barely scratch the surface, but I thought I'd give some kind of a primer, right? So what I wanted to do, just to start off with, was to make a project that I will call Actions, right? Just to basically shadow the same name that GitHub uses. So this is a CI tutorial. CI and automation tutorial. Right. I don't want to initialize the repository, I'm just going to create this. I'm going to take this guy, open up a terminal, open up Vim, open up a terminal again, because I'm that kind of guy. Go into repos. And what do we got to do now? We're going to clone this, right? And then once we're in here, right? Oops. Git up. Hold on. I have done something horrible. There we go. So that's right. So let's git fetch. Done something. Yeah, let's try this. Now I've got all these git config aliases, so if you see something that looks confusing or non-standard, that's because it probably is. I have a lot of stuff that I've sort of done to Git to make it, palatable for myself. And I don't want to get too distracted with that, so maybe that'll be the subject of another video. But we've cloned this thing, we've made an initial commit, right? And the next thing we want to do is actually integrate in some kind of GitHub action, right? So in this video, I'm going to use Rust, but theoretically, like if it was a laboratory repo, you can reduce the friction even more if you just make it a mono repo. So you put a bunch of languages there. With any kind of CI, you can do this. So one of the things I didn't talk about in the initial conversation about CIs is that the SaaS providers, they provide a UI, they might provide free plans for open source projects that are public and make you pay for private ones. They might give you a certain amount of build time for private ones out of the box. I think GitHub does that with Actions. Lots of people use Travis CI, Circle CI, etc. Just trying to think about if I've missed anything. There are also other ones like BuildKite, which is a pretty cool offering that separates this idea of the UI from the infrastructure. So you roll your own infrastructure and then they provide the UI. And in fact, this is actually what I do personally. What I like about it is that I can have actual machines in my house that partly run stuff as well as cloud provided servers. So let's just get on with this. I'm going to move everything in Actions here. Yep. So we're gonna tests. Cool. Now add that stuff too. Actually, git rem cached target because yep, that's why. There we go. So what we want to do is echo target to our git ignore. I'm gonna add that. Cool. Right, and we're going to be a bit savage, and we're just going to push that up. Okay. Yeah, so, okay, when we refresh this, we should have an initial repository. So the way that GitHub Actions work is there's like a GitHub directory, which is sort of where you store all your GitHub related metadata like code owners files and pull request templates and issue templates and stuff. And they get stashed underneath this directory called Workflows. So you can just configure that. So Workflows, Actions, just find the, I think it's this one. There's also a marketplace that has actions. And we're going to be cheeky and just pick one. Actions, just because I want to find something fast. Rust action, silver bullet for quick start Rust. Yes, that's this Rust cargo has 46 stars. I'm gonna go with this. This just looks like a generic one, and this is a template for what we need to have, right? So let's maker-p. That's if there's any directories in the full path that I specify that are missing, make all of them. Otherwise, it would fail. So we want GitHub and we want Workflows, I think it's called. It's not GitHub. So move GitHub to, this is actually a use brace extension. Hub. Cool. So there's GitHub. And we're gonna mdr -o GitHub Workflows Rust.workflow. I think that's the magic incantation. There you go. Set up. Cool. So this says that it's Rust project with Rust actions. Runs on Ubuntu latest. So there's been this modernization with BuildBots. It used to be that there were servers and, you know, I won't go too far into detail about snowflakes and cattle, but the gist was that you had long-running servers, and long-running servers had software on them, and you'd have to patch them and take care of them. And they kind of have this name called snowflakes because the gist is that you are, it's this special thing, and if you killed it, it would take a lot of effort and work to get it back into the shape that you cared about. Whereas cattle, right, you have a whole bunch of stuff at your disposal, like infrastructure as code. What else is there? There's infrastructure as code. There's provisioning software. There's cloud providers, etc., that enable you to kill off a server and just bring it right back, and it'll be the way that you want it, right? A good known state. Because of that change into this cattle-based mentality, you also have containers, which are basically, well, I won't go too far into that, but the gist behind containers in CI is that now we don't have to worry about stuff laying around on disk on this snowflake of a server. We can just sort of, you know, have these servers that are running builds that are completely encapsulated away, and it doesn't have to be Ubuntu that the governing server is. We can just pretend that we're using Ubuntu. There are obvious limitations there, like the CPU architecture has to be the same. Like you can't run x86 64 stuff on an ARM, right? But that's what this runs on thing is, which in other CIs you'll see this named like image, right? And you'll notice that here it says jobs, and this is the name of the job called build and test. So a common convention for, you know, using a CI is to build artifacts that we publish so that people can consume them, whether that's libraries or binaries or whatever. And we can also publish artifacts so that we can deploy them later, right? And we'll get to that in another video. This is sort of action specific stuff. So it says uses actions checkout at master. And then this uses is actions rs cargo v1. Now I don't want to check out master. I just want to check out whatever branch we're on. That's because this is complaining. That's why. Oh man. All right. Go back here and redo this quickly. That's fine. Where are we in this? Okay, so CD actions. There we go. Now we're good. Awesome. So, yep. We want to set this as v1 because that will check out the latest branch. I know that from fiddling around a bit before this video. And then this is using the action that we just found, which is cargo. So now we have cargo available. You can say like run echo hello or whatever on this, but when you have an uses thing, you can say with, and that means with this cargo action, these are the kind of arguments I'm passing to it, right? So here's an argument called command, which is build, and then the args are release all features. So I'm going to call this job build. I'm going to call this actions. And then here I'm going to call this one, test. So this is a very common pattern. So you have something to test. If the tests fail, you won't build anything. And then this would be test. And we don't need it to have that else. We just want test. Do we want anything else with test? No, just want that. So that's really simple. The last thing that there is that there's this name thing here. We'll see what that is in a second. But then you'll also notice that there's this on command. And what that is for actions is the trigger that we talked about, right? So you have a CI, and based upon some action, maybe putting something in the queue or whatever, it wakes it up. For a lot of CIs that are hooked up with like GitHub or GitLab or Bitbucket or whatever, there's usually some kind of like webhook that they'll hit, right? So you've published something and then you'll tell GitHub, oh, here's this payload or this place, right? That I want you to go actually ping with a payload so that their CI or their service or whatever knows about this git push, right? Or this pull request being made or whatever. It doesn't always have to be like that. And in fact, a lot of times like Travis CI and Circle CI and stuff, they'll ask for your authorization so that they can set up those webhooks themselves. That's usually like the nicer, more front-endy kind of thing. But some providers actually have you set up the webhook yourself, which is a little bit nicer because there's less magic and there's less, you actually know how you can tweak things a little better. What I'm going to do is we're going to add this thing. We're going to make a branch called CI, and we're going to set up CI. There it is. How long is it? I might be rushing through this a bit. Trying to make these videos much shorter. So once we make this, GitHub will recognize that there's a workflows file, or should recognize, I should say, if I've done everything right. I think I've done something wrong. So we've done something wrong. Okay. Now I need to figure out where this file needs to go. GitHub Workflows. Okay, right. Yes, that makes sense. So this file, which we're going to close, we have to move that file. Yeah, move GitHub Workflows Rust workflow, and we're going to change this from workflow, whoops, to YAML. Rename rust.workflow. Let's do that. Cool. Now we should have something pop up here. While that's kind of loading, just to kind of give you an idea, there's a whole bunch of things supported here. So to get a gist of what you could do in a CI, you can do linting, although I don't necessarily recommend it. You can do any sorts of actions. And the idea is to not be the machine, right? To reduce friction by not having this stuff running on your own. So these are the two actions, right, that we set up, the two little steps or jobs. So this one and this one. And you see how it has our names, right? So really what we want to do on that, workflows, we'll call this test, and we'll call this one build. Improve naming of jobs. Right. Okie dokie. And you'll see that things passed, right? It ran tests, cool. And then it ran this build, cool. And did some cleaning up. It also checked out our branch here before. Now after that build action, we would generally do something like, shoving it off to S3 with some static storage or whatever. There's even releases that GitHub offers. I would need to plumb a bit about how that ties in with actions. I think you just specify a GitHub token and then you tell them, this is where I want the releases to be. So GitHub Actions releases. And actually create releases via the GitHub Release API. So yeah, here you go. This is something that we could use, right? This gives you a tag name and the release name, whether or not it's a draft or a pre-release. And here's an example of what they're doing, right? We have it running on Ubuntu latest. The name of it is create release. Oh, and let me show you how those names, here's tests and here's build, right? Cool, and that was our name, CI. So let's go back down. Whoops, sorry. And then we'll call this CI. It doesn't matter. That's fruitless. So yeah, let's merge this in. And back to this release thing, right? You'll notice that this kind of shows us that we can provide this GitHub token. That's what I'm looking for. And then we just provide these arguments, right? The GitHub ref, this guy. These will come off of things. I'd have to double check. But I think these are available to you as arguments so that you can pass things out, right? So there's a secrets thing. There's a GitHub thing that seems to have references and stuff. This is probably in relation to the checked out code per this one, maybe. Maybe it's per this one. I'm not 100% sure. But this brings us to an important point, which is leaking secrets. So be really, really careful that you don't expose or echo or anything like that, stuff that could be sensitive. Anything that looks like it could be a secret is probably not wise to spill. And with time, you'll learn that these hashes, they're not really referencing anything, etc. And you can be a bit more, lax. But it's generally good to be a bit paranoid, I suppose. So that's the release one, and we're not going to worry about that. And you'll notice that we have this dangling branch thing. So we'll actually automate that deletion. There's this option now where we can go here and say automatically delete head branches. Didn't used to be there. And it used to be that you'd have to write another action that could delete that. So actions don't have to be related to just CI, right? They can do CI, but they don't have to be related to it. So you can write an action that would take this merge PR, and it would say anytime that there's a merge PR, then delete the branch or something. That would be an example of an action. I guess to wrap this up for today, since we've already sort of shown that we can have that CI workflow, I'd like to sort of finish this off with the idea that we can schedule these. So when you have a project, and let's say that this is the project, and we add a bunch of dependencies, a really kind of modern thing that GitHub has bought and other people are sort of getting in the space of is automated dependency bumps. A lot of what I've talked about with actions used to sort of be done with bots. So you have a bot and you'd script the bot to talk to a bunch of different APIs and everything and perform some logic. So maybe the bot is automating this task of cloning the project every Monday of the week at 9 a.m. UTC. And then it clones the project, looks at the, runs a couple of commands, figures out if there's newer dependencies, and then for every new dependency, lodges a PR. And that's effectively what Dependabot is, and GitHub has bought Dependabot, so there's a bit of a transitioning period until they integrate it completely. But that is an example of automating away some toil that'd be really good. And another example that I don't really see a lot of people doing as a recommended thing is scheduled builds. The cadence of the schedule depends on you and you paying for CI or whatever. Even if it's once a month or maybe even once a week, that would be a good thing. But the nice bit about scheduled builds is that if you are actually publishing artifacts and there are, maybe security updates going on in the background, then you know that you will have, it gives you two guarantees, right? One guarantee is that you know for a fact that this thing builds. So if you want to go back and hack on it, right, you can see that plain as day. And if it is breaking, then you can actually decide, well, is this a pointless project? Do I want to delete it or whatever? Although they may seem like graveyards of good intentions, I think that a GitHub account or a GitLab account or whatever, again, I want to make it crystal clear, I'm not endorsing anybody. All of those accounts that might have a bunch of leftover projects, all of those were amazing learning experiences, right? You had to, bang your head against a rock to figure out what to do in particular circumstances. Or you experimented and you saw what worked and what didn't, right? Or maybe you refined your style of using syntax or exploring language features or whatever. All those things kind of culminated in this cool little, trying to think of a good phrase on the spot. A bed of discoveries, right? A garden of discoveries? I don't know. Forgetting the first part, it is a collection of discoveries that's actually really cool, right? And if you can actually keep those up, you can look back at them and say, well, I can consolidate all these, right? I can put them in an archived repository. And then kind of go and look at them or poke at them or take bits and pieces out of them. Scheduled builds are also really useful to get back into that vein of conversation, where sometimes services go out, right? Let's say now with the popularity of Docker goes offline for a bit or something. The CI isn't working when you want to build. The neat thing about that is scheduled builds with scheduled releases of some kind of artifact, because there generally is some kind of an artifact, right? If it's a library, it's code. If it's object files or whatever, right? If it's a binary, like a CLI tool, then great, there's that available. And if it's an actual service, right, you need some artifact to run to make that service work, right? So that's the deployment step, taking a published artifact and putting it out onto a server. The gist behind that is really fundamentally, it's this idea that if you have scheduled builds, you build in the capacity of having this record history of a whole bunch of snapshots to choose from, right? And then you can at least work with something that's the most recent and the most fresh, that isn't 3 months ago, 2 weeks ago, whatever. It could be from last night, hopefully, right? The last week, maybe. Again, that's the point about you choosing what is the right cadence for me, what is the right time frame for things to have scheduled builds. If we go here, scheduled event. Was it up here that I saw? Oh, here we go. Yeah. So this uses cron expressions. If you're not familiar with cron, don't worry about it. It is a long-lived program, right, which is called a daemon, that is quite common across Linux and BSD flavored Unixes, right? Unixes. And it has this syntax which is kind of mechanical, where you say, I want some action to happen at this scheduled period of time over and over again, right? Some recurring thing. We'll probably set up these scheduled stuff in the next one. I think that'd be kind of cool. But when we do that, we'll explore cron syntax, we'll explore what the action might be. So we might have it actually kick off the whole build, right? Build and test and release as part of that. And that can be like our nightly builds or our weekly builds or our monthly builds or whatever. And once we have that kind of going, we can start thinking about this from the point of view of, okay, now we have a bit of capacity, we're doing some, published artifacts, we have things, tests running. You can do little things that prevent you from pushing code into master, but that's not, you just want to know that the stuff that's on the trunk, right, which is also known as master, always builds, so that somebody pulling down the project, whether it's you or someone else, can get back into the groove of things, that the main master trunk of code is at a good known state, right? And if it isn't, you want to try to get it back into that place as soon as possible. And CI kind of also acts as an alerting mechanism for you for that. The last piece of this puzzle then, because we're going to do sort of this lightning speed CI setup stuff, is deployments, right? And a lot of people will try to cake deployment into a CI where, if it's Kubernetes, it'll hit Kubernetes, or if it's, AWS or Google Cloud Platform or whatever, with a Lambda function, or if it's, ECS, which is their Elastic Container Service Registry, or a similar offering at a competitor, they'll try to hit these services directly, and that's fine. But if you decouple those two, it's actually kind of handy, because then your deployments become, we can focus on things like making deployments actually robust against, 2 deployments at the same time that overlap, and maybe clobber old deployments, etc. Stuff like that. Without going too far into it, I think that's been a really good role. Hopefully this has been kind of cool, watching a really simple and rapidly fast setup of a CI. And just to sort of to finish off with one last thing, the stuff that I didn't fully get to was that you can really add in anything else you'd want to add in to this step. Anything that helps boost your confidence about the quality of your code. So you'll see people running things like, linters, right? Here's ESLint over here. And maybe the linter checks for particular things given the configuration that's in the file, right? Maybe it actually runs a version of the service and tests it against some input, right? With some credentials running in it. Who knows, right? As long as things are kept secret in that regard, that might be satisfactory. There's a lot of cool stuff that you can do, and you can even generalize this as well. Like, here's this GraphQL query one, and this one actually hits GitHub's GraphQL API, but theoretically you could hit many other different APIs and get stuff back, right? If you think about it from the mental model of like town building games, right, or city building games, there's an aspect of self-subsistence there, right? That the creators of the cities are trying to get towards. And here we're doing the same thing, right? We're trying to have this repository that now can live on its own, for the most part. And occasionally, you know, it's spinning the plates and we kind of go in there and have to make some decisions sometimes. The difference between toil and heuristics is something we'll touch on next time too, because you don't want to automate decision-based stuff, right? You want to come in and answer that question for the computer, but anything that like is just a really dumb, simple process that the computer can run over and over and over again, like testing, right? Automated testing is awesome because of this, because it automates away toil. You want to not be the machine. Don't be the machine, right? And that's it. So hopefully this will be picked up again in the next video when we discuss scheduled builds.